Hi, it's Bill here. Kia ora. I want to have a look at code transparency, and really this involves looking at functions, parameter passing, the use of the static keyword, comments, use of braces, and casting. So let's get into this straight away. Have a look at these functions. For instance, here's the function to store a reading. You'll notice that I'm passing it 3 parameters. The first parameter, val. Now this is a pass by value. What that means is that there's a value coming into my function. I can do something with that value. It will have no influence upon the value of where it came from. So for instance, I'm calling this store reading. I'm actually using it up here. I'm passing it the LDR value, which has been read from the ADC. So what's happening in here, if I did anything to the value val, to that variable, then nothing would happen to the one up here in light val. The same for length. In fact, what you can see here, I'm passing in length. I'm actually passing in the number of light samples, which is a macro, which is a constant. So we can't even change this value up here, but we could change it in here and do things with it. But then, of course, it would not have any impact upon at all this macro, which of course is completely predefined for us while the program is running. Notice light readings. Now, light readings is an array of unsigned 16-bit ints. So we're passing light readings in, and we're getting this variable as a parameter for data. I'm going to call it data rather than light readings within my function, just to make it clear that it's actually used within here. But what I'm passing is, I am not passing the full array of variables to work with. I'm actually passing a pointer to the array, which is the address of the first value in the array. And so it's not exactly explicit here to someone who's new to programming in C what's going on, but this is actually passing a pointer to the first value in the array of light readings, so the address or the pointer. In here, you'll see that I'm doing things with this, which means that I'm actually storing some data into, I'm storing this value into that array. And what that means is that the array is actually going to be updated. Because I'm passing a pointer to it, I'm going to be able to update the final value of data in my main loop. And this is called pass by reference. So passing by reference is passing some reference really in C, a pointer to the data so that we can modify it. So this value is modifiable. This value here is not, and of course this one is not. The other thing I want to look at is the use of the static keyword. Now, what static means is that on first entry into store reading, this variable pos is created in memory, and it remains in memory once we leave the function. This value, this variable val is created when the function is called. This value len is created when the function is called. However, those values disappear once the function has finished execution. Pos, because it's been declared as static, means that it stays in memory. And that means that when we re-enter the value again, the value pos is not redeclared, it's not set to 0, it is actually available for us to use with its previous value. So then in this way, we can store our new value into the array at the current position. Now this means that this function is completely self-contained. There's nothing outside it which we are using inside it. So this is a really good way of writing a function. And in terms of your code transparency, writing functions where we're not actually using values outside the array is really good practice. For instance, if we hadn't put this here, and instead we had used number of light samples in here instead, it's got exactly the same function. However, now it's dependent upon something outside itself. And so that's not a very good practice with functions. You want to make sure that the function is fully self-contained. The other thing about functions, of course, is they serve one purpose. They have a single purpose. We try not to do multiple things inside a function, and this just makes your code much more transparent, easy to read. let's have a look now. I said that this was passing the pointer to the array, and here I'm passing it in a slightly different way, but this is probably a bit clearer, the fact that we're actually using a pointer. We are not, you know, you can't confuse it like you might try and confuse this with passing all of the data. But here what you're doing is you're passing clearly a pointer. I'm still using it in exactly the same way down here. I'm using it as just as I had up here. The other way to use it is I've put into this. Here I'm passing it clearly as a pointer, but what I'm doing here is I'm declaring another pointer. In my for loop, I'm copying one to the other, and then I'm updating this pointer so that we can actually iterate through the whole array and create a total, which is, you know, dereferencing the pointer here so that we can get the values out of the array. Now, I just want to just really clearly here, this is passing in a value, this is passing in by reference, okay? Really important. The other thing I want to talk about here is comments. I haven't put a lot of comments in here. Well, some of these things are fairly self-explanatory. Get, mean. Now, a lot of people have a very formal way of writing comments at the beginning of a function to explain what it is, what the parameters are, and what it returns. I haven't bothered in these. When you enter the workforce, you'll find that the organization that you are working for has its own rules. I do want to have a look at one set of rules, and I want to do that around casting. So I'm just going to take this comment out here. I'm going to take this comment out here. And now, if you'd seen this for the first time, you might not realize that what's happening here is a cast. So what we've got is we've got difference, which is a float up here. We've got mean, which is coming in as a float. And this data that we're using is actually unsigned 16-bit. Now, that means that there could be some confusion in your mind as to what's going on here, because this is an unsigned 16-bit minus a float. So what happens in this situation? What gets converted and what doesn't? Now, automatically, this is an implicit cast, so we don't actually need to specify it. The thing, however, is that casting is extremely dangerous. And so it's really nice to make a good habit of actually just being explicit with your casting. So actually, I had that comment there before, explicit cast of unsigned 16-bit int to a float. Now, it's actually implicit, I don't need it, but casting is dangerous. And I just want to give you a reference for this. There's an organization called Bar Group, and the guy there who runs this organization has written a little embedded C coding standard as high quality practices which avoid bugs. Okay, they do a lot of software, and you can download it as a free PDF version or just look at it online. But what I want to do is I want to have a look at casting, and it says each cast shall feature an associated comment describing how the code ensures proper behavior across the range of possible values. Okay, so even though in my code I have got an implicit cast, I've been explicit with it, which is really good practice. So I've had a look at functions and, you know, giving them a single purpose. I've looked at the static keyword and I've looked at casting. I want to look at comments just maybe a little bit more. Down here, I've put in that this is the population variance. Sample variance would be length -1, okay? And this is the population standard deviation. So just these explanatory little comments help us understand what's going on. What else? I haven't put many comments in here. Really, it's fairly clear what store reading does. It's fairly clear what send a double is, especially because up here I put send int, sent value to comport. Really, comport's perhaps not a useful term. Send to USART, okay, is perhaps a better comment. The rest of it's fairly self-explanatory. Get Z-score. This is all about naming, you know, naming conventions, just making things explicit. Yeah, I think the other thing I want to have a look at is the use of braces. What you'll see down here, that what we've got is a brace because we've got a couple of things happening inside the for loop. Say, for instance, that I didn't want to send this, and so I could make this as completely satisfactory for loop. However, it doesn't have the braces, which means that should I wish to do something different with it in the future, I have to remember to put the braces in. It's much clearer, even if there's only one thing happening inside a for loop, a while loop, or an if statement, that you put the braces in. Because later on, when you add something to it, you might not realize that the braces are not there and just sort of trip over yourself. Okay, here's a bit of extra white space. I don't know why it's there. It's not useful. Okay, just trying to make your code readable. Now notice here that I've declared this variable total, and I'm using it as total, and then I'm dividing it by length and returning it, but I'm actually returning the mean. So I put a little explanatory comment in here to say I'm returning the mean. I could, of course, declared two variables, one for the total and one for mean, but I've reused the variable. Otherwise, I could have just called this mean, which means that throughout this, I could have just used this. Okay. In each case, then I might want to put a comment in this case to say that I'm actually going to use the mean variable to calculate the mean by adding and totaling it all a little first, or as what I've done previously, I've just said return the mean down here because I'm not returning the total, I'm returning the mean. And so someone would read this code and think, what exactly is going on here? It says return mean, but it says return total. Oh, I can see what's happening. He's reused the variable here to get the mean and passing it back. So I could, of course, made it really explicit and gone float mean equals that over length and gone return mean. I could have done something like that. And of course, I would have to do this float mean equals total slash length. And now I could do that. The other thing I could have done is let's go back to what I had before. I could have just returned total slash length and not done this step at all, which of course would return the mean. Now, I don't like to do that myself because when I'm debugging, I often want to look at these variables in their different states. So I generally would do something like this, just so that I can actually see what total is before I returned it if I'm going to do some debugging. Down here, I've got no comments at all. Get Z score, Z equals value minus mean, Z divided by standard deviation, return Z, okay? And I've actually used Z. So at this stage, this is not the Z score, this is the Z score, okay? And it's just reusing variables within a simple little function like this is quite clear, but if you're going to reuse variables in a bigger function, then maybe it's a bit safer to do something a bit more explicit as to what you're doing. So I've talked about comments and braces and casting. Oh, one more thing about braces. You'll see that down here in this ADC function, I've actually expanded this from the one that's in the template. The one that's in the template uses this code here. Now that there is not very clear. It breaks the rule about not using braces. That is much clearer. Now that really says to someone, while this is true, do nothing. So we're waiting for this to become false to break out of this loop. This is more explicit. This is more explicit. And of course, what I had before is even more explicit. So, you just want to think about that, especially this blocking code here, because if I do this, then it's really tricky to see. It's really easy to miss the semicolon and think that, while that's, someone might think that actually this is a while loop returning ADC word, So we want to make sure that we're very, very clear with what we're doing. And this adds to code transparency. And the reason we're really looking for code transparency is ultimately, at the end of the day, most of the work that happens in software happens after a product has been shipped. It's rewriting and it's redoing and changing things. And really, you just save yourself an awful lot of headache if you have good practices to start with. Work it out on the small things and they'll work really well in the big things. Hopefully this has been helpful to you. Cheers.